Today in this video we're going to be talking about object pooling, and I want to make this video specifically for complete beginners to object pooling. So if you've never touched object pooling, or if you've heard of it but you don't know what it is, or if you've never even heard of it and you don't know why you should be using it, this video should be perfect for you. So I'm going to show very basic examples of using object pool in a real project that we create here. And then when you're completed with this, you can learn how to expand on those and make more advanced features on your own. But I want to keep this very basic so nobody gets confused by it or you get discouraged and you don't want to use object pooling anymore. So I'm going to try to make it very bare bones, and all we're going to do is a basic pool. So first thing to talk about is what is object pooling. So if I go into this little project I made here, and this is just a simple little shooter where you just move around, and as you fire you can see all of the lasers get created as a separate laser, and then they get destroyed a few seconds when they're off the screen. So this is a perfect case for when you want to use object pooling. Object pooling you want to use when you're using repeatedly similar objects in your game, and you're constantly creating them or instantiating them and then destroying them. So in Unity, two of the heaviest things you can do on the CPU is instantiate new objects and destroy objects. So the idea of object pooling is to alleviate that, and you make what's called a pool of all these lasers, and then we just borrow them as we need them. So I'm going to pause this here, and if I just select one of the lasers, the very simple concept of object pooling, and like I said, you can get a lot more advanced and you can learn that later, but when you really get down to it, what object pooling is when this laser that you're firing gets off the screen here, normally you would destroy that, and then when you need a new laser, you create a new one and repeat over and over again. With object pooling, what you want to do is once it's off the screen here, we're going to take this laser and actually move it over to the side somewhere. Doesn't matter where you actually put it, but you move it off somewhere where it's not on the screen, and then you disable it. So we disable the game object, and then it's technically still there, but you don't see it. It's kind of in limbo. And then when you're going to go to fire another laser, instead of instantiating it, what you basically do is say, hey, object pool, give me the next laser available. So it would give you this laser, you would enable it, and then move it to the position and the rotation where you want it, just like if you instantiated it. And then it acts just like a normal object you would create. So it would keep firing up, and then when it gets off the screen, the process would repeat. And when you're doing this, moving an object and enabling and disabling an object in Unity takes next to no CPU usage. So this is going to be very optimized for your game instead of constantly creating new objects. So I'm just going to go into my code for this project here and just comment out this. And here's a heavy laser blast I made as a better example. So you can see when you're firing this, you can easily reach thousands of objects in your scene before they actually get destroyed. And Unity is constantly processing these, destroying them, creating new ones. This is the perfect example of when you would want to use object pooling. And then I also have an enemy spawner here. And this is just spawning a ton of enemies. So this is the project we're going to make right away. And what we're going to do is use the lasers that we're spawning as an object pool, and then all of these enemies as well. That's another perfect use because all of the enemies are the same prefab that we just keep instantiating. So instead of creating them, we can just reuse the same enemies over and over again. So that's the bare basics, and when we're working on it, we're going to actually see the frames per second that you get before object pooling and then after object pooling, and you'll see the difference it'll actually make on your game. And even a simple game, you're going to notice major performance increases on this. So let's get right to it and get started here. Okay, so we're going to start a new project here. And if you didn't want to follow along and you just want to start right at the object pooling part, you can look in the chapters of the video, and there is a section where you can just click to start there. And you can download this sample project, which is the one we're going to create right now. It's in the links below, and you can download it straight from GitHub. I also have a link to the completed project with the object pooling that we make at the end of this video, so you can download that directly as well and look at it there. Or you can just skip to the object pooling part in this video and then follow along with your own project. Whichever you decide, all of them are going to be viable options here. So this project's going to be quite simple, but I do want to mention that I'm not going to be explaining everything in the project as we create it, so it kind of expects you to know the basics of Unity and C# programming. Once we get to the object pooling section, I'll slow down and explain that a bit more thoroughly. So let's create a 2D project here, name it whatever you want. I'm just going to create this one as pooling. So now that we got the project open, the first thing I'm going to do is get some sprites to use. So if you want, you can either get them from the link to the GitHub project in the description there, or you can go right to the Kenney.nl website like I'm going to be doing here and just follow along, or use any sprites that you choose. So if you aren't familiar with Kenney, it's completely free art that you can use in commercial projects. You just go to Kenney.nl, and the first pack I'm going to use here is the Space Shooter Redux. And the other one I'm going to use for an explosion is the Pirate pack. So I'm just going to download and save both of these. Just extract the packs, and then the only folders we actually need out of here is the PNG one. So I'm just going to take those and drag them both into my project here. I just made a folder named Sprites in my project and then dragged both in here. So now we have all the sprites in the project. And the first thing we need to actually do in our game is make a player. So just pick any sprite that you want for the player. I'm just going to pick this orange one here and drag it in. And then let's rename that to be player in the hierarchy. And just before we get too far, I just want to mention the code and everything we set up in here is not very good game structure. The way we do the player movements, not great either. This is just a quick prototype just to demonstrate this. So you would want to try using some better code and structure if you're making a real game out of this. So on our player, let's add a player controller script. Let's open this script up, and first thing I want to do, I'm just going to make a serialized field float value for move speed, and I'm going to set it to 8. This is going to control how fast a player can move around in the scene. We're going to need a prefab for our laser, so let's make that right now as well. Let's make a method for movement, and in here I'm just going to use a simple transform.translate to move. Now for the actual vector3 that we pass into translate, I'm just going to create a new one, and for the x I'm going to use input.getAccess horizontal, and then for the y input.getAccess vertical. And we don't need anything on the z, so 0 there. And then I'm going to multiply this vector by move speed and time.delta time. So all we're doing is taking direct input from the keyboard or a gamepad, multiplying it by our speed and time.delta time, and that's how much we're going to move per frame. We're not even going to worry about collisions on our player, because for this example we don't need them. So that's it for the movement. All we have to do is call this method in update. So we can test this now, and we got simple movement, but we can move off the screen. So we'll fix that in a minute. I'm just going to select the camera, change the background to black, and then I'm just going to change the size of it a little bit here too to make the game space a bit smaller. So you can find whatever you figure you like here. 10 seems a good spot. And then I'm going to set the game view to 16:9. So let's go back to our player controller, and now we're going to set it so the player can't leave the screen. And this is something we could have left out of this sample project, but I figure some people might like this as they may not know an easy solution to that. We need to make some variables to store our screen bounds. So I'm just going to make a float variable for x min, x max, y min, and y max. And we're going to store in these the corner positions of each corner of the screen. In start, I'm going to call a new method called getScreenBounds. And then let's make that method below. We need a reference to our camera, so I'm just going to make a variable called myCamera. Then in there, I'll store camera.main, which is our main camera in the game. And now for xmin, what we need to do is we're going to use myCamera, and then there's a method on here called viewport to world point. And we're going to use this to convert the corner of the screen to a world position. So if you've never used viewport to world point, you need to pass in a vector, but it's not the way you would normally use a vector. So the way it works is the X and Y position is based on a percentage from 0 to 1. So the first value we need here is the x. So 0 on the x will be the bottom left corner of the screen, and then 1 on the x will be the bottom right corner. So think of it like a percentage from 0 to 100%, and you're moving from left to right and bottom to top. So for x, halfway across the screen would be 0.5. So to get a better visual of this, if we go back to our game view here, and we look on the game window, so here, the bottom left corner of the screen, this is going to be x0, y0. Then as you move to the right on the x, it goes up to 1. So 100% would be 1 on the far right corner. And then it works the exact same for the y. So the bottom left corner is 0x, 0y. Top is 1 on the y. So top left corner would be x0, y1. And then the top right corner would be x1, y1. This is something I plan on making a more detailed tutorial on the future, so keep an eye out for that video. So for the x min, we want to use 0, 0 for the bottom left corner, and then for the z position, I'm just going to use a feature on the camera called myCamera.nearClipPane, and this is just going to return the clipping pane on the camera, so basically where the camera view actually stops. And now this is going to return us a vector. We only want the x minimum, so we're just going to do .x. And that's all we need from this here. We don't care about the y on this one. And I'm also just going to make a quick float variable here. I'm just going to call it ship size. And I'll set this to be 0.5. All this is we're going to use this as an offset for the ship size so you don't go half off the screen, since we're going to be basing it off the middle position of the player. And now I'll just add ships plus ship size at the end of this. And that'll just keep us fully inside the screen. Now to get our x max, it's going to be almost the exact same thing. So we can just copy and paste this whole line, and then all we have to do is change the x value to 1 to get the right side of the screen. And since we're on the right side of the screen, we just need to subtract the ship size, so that way he stays to the left. And then for the y values, we can just copy both of these lines, change it to y min and y max, and then we just need to change it to be 1, 1 for y max. So then we get the bottom of the screen and the top of the screen. And then at the end, change .x to be .y instead. So this gave us the size of the screen, but we haven't actually clamped the player yet. So in movement, right after we move the player, let's do transform position equals. So we're going to assign it a new vector 3. And then for the x, we're going to do mathf.clamp. We'll pass in the x value of the current position. And then we're going to clamp it between x min and x max. And then exact same thing on the y, just using the y values. And then 0 for z, as we don't need to worry about z. Okay, so now after we move our player, it's going to check that position and clamp it inside the screen space. Let's go and test it out now just to confirm. So bottom and left are working. Hit the top, and then we just need to test the right as well. And everything's working here. Next up, we need to make a laser. So I'm just going to pick this first one in the lasers folder and drag it in, rename it to be laser. Now on the laser, I want to add a rigid body 2D component. We don't want any gravity, so set that to 0. And we don't want any angular drag, set that to 0 as well. And we also want to add a box collider now. Make sure it's box collider 2D. Just going to zoom in on the laser a bit and then move it out of the way here. And that box collider looks good enough. So we're just going to stick with that. And now we want to add a script to this laser, and I'm just going to call it laser. Let's open that up, and we need to get a reference to our rigid body 2D. So I'm just going to call it my rigid body. And then we also want a velocity variable for how fast this is going to be moving. So I'm going to call it move velocity, and I think 400 should be good for this one. I'm going to get rid of start and use awake instead for getting components. And we're just going to get the rigid body component to store in this variable. Since we're using physics, I'm going to get rid of update and put in fixed update instead. And we're going to want to set our rigid body's velocity in here. Since this is a 2D game, our up direction is going to be on the y, so we're going to set it to transform.up, which will be on the y-axis, times move velocity times time.delta time. It's always a good idea to test to make sure you get the direction right. So yeah, our laser flies up when we hit play. Now just click and drag that laser into the project and we'll make it into a prefab. Let's select our player and then drag in the laser prefab from the project down here. And then let's also delete the laser prefab in the hierarchy. We don't need that. Let's go back to our player controller, and now in update after movement, I'm going to call a new method we'll call shoot. And then let's create this method below. And I'm just going to do a if statement with input.getKey. And I'm going to use key, not key down, so we can just hold down space. And now we're going to need to tell it where we want to spawn the lasers. So let's actually go back into our game. Now the way I'm going to make it use the fire positions is I'm just going to make some children under the player. And I'll call them shoot position, and this is going to be where each laser is going to be spawned. So we can make as many children under player as we want, and it's going to spawn a laser at all of these positions. So I'm just going to make a bunch of them here. I'm going to keep duplicating them and just place them at some different positions and rotations. You can make yours however you want and position them and rotate them whichever direction you want for kind of a multi-spread shot laser shooting system. Okay, so I'm just speeding this up a bit while I just make a whole bunch of these. You can kind of see what's going on and just make yours however you want. You can make more or less, doesn't matter. Okay, so it looks like I got about 15 of them there. This should be good for a demonstration. So now back in our shoot method, we can just do a simple for each loop. And if we do transform, just name it T in transform, the lowercase version. This is going to loop through every child under this object, and the only children we have are our shoot position. So in this case, this is going to work fine. In a normal game, if you had other type of children, you would have to do a bit different of a system here. Now in here, we just want to instantiate a laser prefab, and for the position, we'll use t.position and t.rotation. So now this is going to loop through every child and spawn a laser at their position with their rotation. So now this system is going to work, but we don't have a cooldown yet. So if we test this and we start shooting, it's going to constantly shoot every frame, and we're actually going to see them collide with each other because they all have rigid bodies and colliders. So as you can see, now they're all colliding, going all over the place. Let's fix that collision issue first. So select the laser. Under layer, let's add a new layer, and we'll call it laser. And now select the laser again and assign it to the laser layer. Let's go to the edit menu and project settings. And then under the physics 2D section, at the bottom we have the collision matrix here. Uncheck the check next to laser colliding with laser. So now it's going to fix the collision issue. And running our game again, you'll see there is no collisions now, but we still have the cooldown problem. So let's go fix that next. So let's make a shoot cooldown variable. And this is just a float. I'm going to make it set to 0.1 second. And I'll make another one. This will be our timer, and I'll call it shoot counter. So now when we're shooting, we also want to do an and check in here. And just make sure our shoot counter is greater than the shoot cooldown. So basically we're checking to make sure enough time passed before we can shoot again. Now after we fire, we need to set shoot counter back to 0 to reset it. And lastly, in update at the end, we just have to increase our shoot counter every frame. So let's just update shoot counter plus equals time.delta time. And that's it for the cooldown. So we can go and test this. And you see it's a bit slower than it was, but it's still quite fast, and I like it that way, so we're going to keep it like that, but you can adjust it to any speed that you want now. Alright, so now we have our player working and a laser and being able to shoot, so the next thing we need to do is make an enemy. Just pick any enemy sprite you like and drag it in, and we'll name this guy enemy. Let's add a rigid body 2D and remove gravity as well as angular drag. And then let's next add a box collider 2D. And I'm just going to leave it with the default size. We don't have to be picky just for this project. And lastly, let's add an enemy controller script and then open that up. And just like we did in the laser script, we need to cache a reference to the rigid body. So I'm just going to make a variable and get that in awake. And we'll just get rid of start and update and replace it with fixed update. Now I'll set the rigid body's velocity. And this time we're going to set it to vector2.down. And then again, we'll multiply it by a move velocity and time.delta time. Now we just got to make that move velocity variable, and I'm going to set it to 100. And let's just go test this. We'll move our enemy up, hit play, and he should fall down. Okay, that's working fine. Now let's select our laser and let's change the collider to be a trigger. And then I want to make a tag. So let's add a tag, laser. And then we just need to assign this tag to the prefab. So go back to laser and assign it. Now let's go back to the enemy script and let's add in onTrigger enter 2D. And we're just going to check if the collision.tag equals laser. So if the enemy got hit by a laser, then if that's the case, what we want to do is let's destroy the laser first. So destroy collision.gameObject. And then after that, we want to destroy the enemy as well. So let's just do destroy gameObject. So if we test this now, we can destroy the enemy, and whatever laser hits the enemy will destroy as well. Now another thing I'm going to do on the enemy is I'm going to make a method which is onBecameInvisible. And this is a built-in method when the enemy with a sprite render goes off the screen. This is going to run. So we're just going to destroy the game object. So all this will do is if the enemy goes off the screen, it destroys itself. We can test this one out too. So if we run it, you see the enemy in the hierarchy, and as soon as he leaves the camera, he destroys. So now we just about have our working prototype that we can use for object pooling. We just need a spawner. So create a new object. We're going to call it enemy spawner. I'm going to reset the transform and then add a new script called enemy spawner. Now for this script, again, this isn't very efficient. It's just a quick little project. You would want to come up with something better than this for a real system. But what I'm going to do is go back to our player controller. I'm going to copy all the screen bound stuff, including this getScreenBounds method, and paste this into the enemy spawner. And then I'm going to call it from start. So this is going to get our screen bounds just like it did on the player. Okay, now that we got that, let's make a variable to hold our enemy prefab. So now we need a minimum and a maximum spawn time variable. And all this is going to do is we're going to pick a random number in between these two values. So I played around previously and I found these both work pretty good. Now I'm just going to make a coroutine called spawnEnemy. And I'm just going to put a while true loop in this coroutine. So it's going to constantly loop forever. And inside this loop, let's instantiate our enemy prefab. And then for the position, we're going to make a new vector 3. And for the x, I want to use a random value between the minimum and the maximum. And for the y value, we want them just above the top of the screen. So I'm going to use y max and then just add 1. So he starts 1 unit above the screen and then drops in. And for the z, we can just do 0. And we're not worried about rotation, so we'll just use quaternion.identity. And now the important part for this loop, we need to put yield return new, wait for seconds. And we're just going to pick a random number between the min spawn time and max spawn time. And then that way this loop is going to run forever. It's just going to have a delay between each one, somewhere between these two values. And we just need to remove all this plus and minus ship size stuff off the screen bounds because we're not using that on this method. And now we just need to make a prefab of our enemy. So let's drag him to the project folder, delete the one in the scene, and now select our enemy spawner, and we just got to drag in the enemy. And we just forgot to call our coroutine, so let's go back to the script and in start. So after getScreenBounds, let's do start coroutine, spawn enemy, and that's going to start spawning the enemies. So let's go test this out. And we see that's working, but the enemies are colliding and pushing each other around because they have colliders. So let's go back and select our enemy, and we're going to create a new layer called enemy. And then we just need to assign this layer to the enemy. And once again, back to edit project settings under physics 2D. We just need to uncheck the enemy layer from colliding with the enemy layer so they don't collide with themselves. Now when we run it again, they're not going to push each other around. So they do spawn on top of each other. We're not worried about that for this video. That's fine. So that's working great. The last thing I'm going to do, just to spice it up a bit, I'm going to make a little explosion. So these sprites here I'm going to use. And to me, the order looks backwards. So I'm just going to rename them in the order I want them to be in. And then if you click and select all 3 of them, now if you drag that into the hierarchy, Unity is automatically going to turn it into an animation clip. So I'm just going to save this here. I'm going to make a new folder called animations, and then I'm going to call it explosion. So now if we move that off to the side a bit and run the game, you're going to see it animate and we have an explosion we can use. Let's just drag that down to become a prefab, and then we can delete the copy out of the scene. And now back to the enemy script, and at the top we just need to make a reference to our explosion prefab. So we're going to want to spawn this in this if statement, where if we collide with the laser, just before we destroy the laser in ourself, we want to instantiate this explosion at our current position. Now just back to Unity, let's select our enemy prefab, and we just got to drag in the explosion to the script here. And then if we run the game, we're going to see the explosions are creating, but they never destroy themselves. They constantly loop. To take care of this on the explosion prefab, I'm just going to make a script called self-destruct. And in the script, let's make a serialized field for a destruct time. And this is just going to be how long it takes before it self-destructs. So by default, I'm going to set it to 1. And in start, right when the object's created, we're going to call destroy on this game object. And we're going to pass in destruct time. So it's going to call destroy as soon as it's created, but it won't actually destroy until destruct time has passed. So now if we look on the script, it has a self-destruct time here of 1. And while we're at it, we don't currently destroy our lasers at all. So we can actually just add this self-destruct script right to the laser as well. And we can just set this one for a longer time, so maybe like 5 seconds. So now we have a working prototype for a game we can use to object pool. Let's test it out, and everything seems to be working. We can destroy enemies, they explode, the explosions disappear. So that's all in check. So I'm just going to set it to full screen, and I'm going to put the stats panel up so we can run it here. And actually, the newer versions of Unity, they don't full screen automatically now. So if you stop that, and if we click on the aspect ratio, this first checkbox, this low resolution aspect ratio, if we uncheck that, now it's going to actually full screen. So if we run our game now, you can see the actual game running and our performance. So on my computer right now, you can see it's kind of bouncing around anywhere from like 800 FPS to like 600 it looks like. And we're getting about 1 to 1.5 millisecond per frame for load time here. But you can see as you're moving around, the more shooting and the more enemies are on the screen, all of that, it impacts the game, and the FPS drops a lot. Whereas if I stop shooting now, you can see it climbs up almost to 1,000 frames per second. And then once I start shooting and killing all the enemies again, it's going to start dropping down again. So this is what we're trying to help by using object pooling. And then we can take a look at it again. You won't see a huge increase when we do the object pooling because this game's fairly simple, but it will be noticeable. We'll probably see, I'm guessing, 100 to 200 FPS improvement. So thanks for watching this part. I hope it was helpful to actually make the game so we actually use our own project for it. I know I went through that very fast and didn't explain a lot of it. I did expect the common Unity and C# parts to be known already at that point. But if it was something you struggled with and if you wanted a more thorough video on something like that, leave comments below and I can work on that for the future, or I can make like a primer video to prepare people for this. So just leave that below, and now we're going to jump into actually using object pooling. The first thing we want to do is create a new empty object, and I'm just going to call it object pool, and then reset its transform, and I'm going to add a script to it called object pool. So now to keep this very basic and really user friendly, what we're going to do is we're going to use queues to start our object pool. So if you've never used a queue before, it's built into C#. It's very similar to a list, except the way it works is it's first in, first out. So there's no ordered numbers, there's no accessing an index. It's just you access whatever is next in the queue, and that's all you get. So it's actually very similar to going to, say, Walmart or Best Buy and waiting in line for the teller. So when you're standing there, the next person that's going to get helped was the first person in line. That's exactly how a queue works. So to get started, I'm going to make a serialized field of a private game object, and this is going to be our laser prefab. So now creating a queue is very similar to creating a list. So we can do private and then queue, and then you use angle brackets just like a list, and you put the type in it. So in this case, we're going to use game object. And then you just put the name. So I'm just going to make this one laser pool. And then just like a list, you have to initialize it. So we can do equals and then new queue, or type game object, and then just our brackets. So if you've never used a list before, this might be a bit confusing. You might have to check a quick video on reference of how lists work. But if you have, this should look very similar. It's just a queue instead of a list. And I'm going to make one more serialized field here, and this one's going to be an integer called laser pool size. Now this isn't going to be the max size of the pool. That's going to be as big as you need it to be. This is going to be how big the pool is when it starts. So when you start your game, it's going to create this many items. So I'm just going to set it to 10 for now, and then we can change this later. So the way this is going to work is we're going to make some code right away in start, but what it'll do is when the game starts on the first frame, it's going to create as many items as we have set in the laser pool size on the first frame. So all of your initialization is done at once. Normally this is going to be so small on most games you won't even notice a delay, but if it is a bigger game, what you'll want to do is kind of spread that out over a few frames. Like you can load it in a coroutine so it's not all at once. And on a bigger game, you usually have a loading bar when you're starting your game. You just kind of incorporate it into there. That way all the loading's done at the start of the game and not while the game is running. So that's a bit more of an advanced topic, but I wanted to kind of give you the basics so you know where you're going to eventually go with this object pooling. And that's kind of the end result. So to get started, we're just going to want to work in start here, and we need to make a loop. So we're just going to use a for loop, and we'll just start it with the basic int I equals 0. And then we want I less than laser pool size, and then I plus plus. And now inside this loop, we're just going to make a game object called laser. And we're just going to use instantiate laser prefab. And notice we don't have to bother with the position or the rotation because this is going to go right into the pool. So none of that matters. You're going to deal with that when you grab an item from the pool and then you put it where you want in the game. So now that we instantiated that, we just have to add it to the queue or the pool if you want to think of it that way. So what we can do is we can use laser pool, and the way you add it is you type .enqueue, spelt like this, and what that'll do is in brackets you pass in an object of whatever type you made the queue of. So in this case, it's a game object. So we can now pass in any game object, and it's going to add it into this queue. So in this case, we want to pass in the laser that we created. And now that we added the laser to the queue, all we want to do is set our laser to be not active. So we can do laser.setActiveFalse. And then this way, the object's disabled, and you're not going to see it in the game at all. So now if we go back to Unity, and if you look at our object pool, so it's got a laser pool size of 10, and we just got to drag in our laser prefab to the slot here. Now let's run our game, and actually let's just stop and take it off full screen, and run it again. And you're going to see in the hierarchy here, right off the hop, it creates 10 laser prefabs, and they're all disabled. So that's our queue or our pool right here. So in an actual game, you wouldn't want to leave them cluttering up your hierarchy like this though. You'd want to move them under a parent container just so you can keep it nice and tidy. But we're just going to keep it as brief as possible for this scenario. So now we have a basic pool, but we have to actually get those items from the pool. So let's make a public method here, and it's going to return a game object, which is going to be our laser. And then I'm going to call this one get laser from pool. So the first thing we're going to want to do in here is we're going to want to make sure there is an item available. So I'm going to do an if statement, and I'm going to do if laserpool.count is greater than 0, which means there's at least one item in that pool. So now if there is an item, what we're going to want to do is we're going to make a game object and just call it laser. And then we'll set this equal to, and we're going to use our laser pool. And to get an item from a queue, all you do is type DQ and then open and close bracket, and that's it. You don't have to pass in any kind of index or anything. All it's going to do is grab the next one available. So it's very simple and clean. We don't have to worry about indexes or anything like that. So now that we have a reference to that laser, we're going to want to tell it to become active again. So just laser.setActiveTrue. And then we want to return this laser. So when you call this method, you're basically going to say, hey, give me the next laser in the queue. And now we're also going to put an else statement, and this is going to get called when there is no items in the pool. So for now, we're just going to return null, and then we'll come back and deal with this later. So now if we go look at our player controller, in our shoot method where we instantiate the laser, this is where we're going to want to call that method from the pool to get the next laser. So now anytime we want to actually access this object pool, like any other game object we don't have a reference to, we're going to have to create a variable and then do a search for that object. And we need to actually find a way to get a hold of it. So to make this easier, what I like doing for object pools, because I never know where I'm going to have to access them from, I use what's called a static. So if you're not familiar with that, I'll show how it works here. So in our object pool, right at the top, we can create a public static item of type object pool, and then we're going to call it instance. So the way a static variable here is going to work is there's only going to be one item of instance across our whole game. So even if you have 10 different object pool game objects in your scene, there's only going to be one instance. And then that way we can access it directly. This is actually easier to understand once you see it in use here. So let's just dive right in. Let's add an awake method. And in here, we're going to do an if statement to check if instance equals null, which means instance has never been used yet. And this is the first object pool. So if that's the case, we're going to set instance to be equal to this object pool. So now if you do have multiple in the scene, only the first one is going to be referenced in this instance variable. So now we have a static instance, and our getLaserFromPool method there is set to public. So now we can actually go back to this instantiate command in the player shoot method. And now let's type object pool with a capital O for the class. And if you type dot, now you can access instance. So you don't even have to search for it. It's already there and it knows which one you want. And now let's access that public method. So we can do getLaserFromPool. And that's it. So we just have to assign this into a game object. So let's make one called laser. And now we grabbed our first laser from the pool. So let's use this. Let's access it, laser.transform.position. And we can assign the position the exact same thing we had when we instantiated. So t.position. And then let's do the exact same thing for the rotation. And now when we grab that laser from the pool, it's going to move to the exact same spot where we were instantiating the laser before. So now we basically grabbed an object from the pool and moved it to the position we wanted. And that's exactly what we needed. The one thing we got to do here though is we got to add in a null check. So we're going to do if laser is not equal to null, and then let's add these in there. So that way, if we check the pool and there's nothing in it, we don't try to move the object because it doesn't actually exist. So now if we test this, notice when you try to fire in the game, all we can fire is those 10 because we created 10 in the pool and we're grabbing them, but we haven't told it to return them to the pool yet, so it runs out. Let's confirm this. Let's select our object pool and let's change the size to 25. Run the game again, and now when we shoot, you see we shoot 25 this time. So getting them from the pool is in fact working. So when you're starting your game, you usually don't know how big of a pool you're actually going to need. So let's address this here. Let's go back to our object pool, and now in this else statement where we're returning null, let's remove this return line. And what I'm going to do is create a new game object, call it laser, and we're just going to instantiate another laser prefab. And then right after this, what we're going to want to do is return this new laser. So what this is going to do is if the if the pool doesn't have enough, it's going to create another laser, and we don't have to worry about adding this one to the pool because we're instantly returning it. So it'll get added to the pool once it's returned back later. This is called expanding your pool, because if your pool is not big enough and it runs out, but you want to set it to expand automatically, this is how you do it here. So just a few words on this though. You do want to try making your initial pool size as close to what you need as you can guess, because the whole idea of object pooling is you want to try to limit not creating objects at runtime. You want to create them right at the start. So with an expanding pool, if you don't make it big enough, you're still going to get some lag and delays, because if the pool is not big enough, it has to start creating new objects while the game is running. But as a fail-safe, in case you don't plan enough and it happens, this is a really good approach to work in there. So the main point there is just don't make your pool very, very small and rely on it expanding, because that kind of defeats the point of object pooling. And one other thing to mention, in case it's not clear in the code, once your pool does expand with these, it will never shrink. So you don't have to worry about reinstantiating objects every time if you're short. Once it expands, it's always going to stay at that size. So unless you need even more next time, we never actually delete anything from the pool. We're just borrowing them and then adding back. So when you expand, you're just adding another one to add back in. So if we run the game again now, we'll notice we can shoot regularly. So we hold down spacebar, we constantly shoot. But if you look in the hierarchy, none of these lasers are actually staying. They're all being destroyed yet. So we're not adding anything back into the pool. We're still deleting everything. So that's the next step we need to take here. Let's hop back into the object pool script here, and we're going to make another public method. This one's going to be of type void, and we're just going to call it return laser to pool. And this time we have to pass in a game object, and we're just going to call it laser. So this is the actual laser that we're going to return to the queue. And to add something back into the pool, all we got to do is access our laser pool.enqueue and then add the laser. So now that's back into our queue or our pool. And then we just want to make it not active again. So we'll do laser.setActive false. And now that laser is back in the queue just like when we started. So now we have to kind of backtrack and refactor every spot in our code where we're destroying a laser, and we have to change that to add it back to the queue now. So if we check our player controller first, we don't have anything there. And the one thing to mention, we don't actually need this null check anymore on the laser, but it is always good to do a null check anyway, so I'm just going to leave that in there. So our next script is self-destruct, and we are going to have to actually do something here. So if you look, we're actually using that on our laser to destroy it, and we don't want to do that. We need to go to the pool. So let's remove self-destruct from the laser prefab. And instead of that self-destruct, let's go to the laser script. And just like we did before, let's add on became invisible. So anytime this laser's off the camera, then we're going to add it back to the pool. Now to actually do this, all we have to do is access the object pool.instance and then .return laser to pool, and let's just pass in this game object. And that's got to be the lowercase game object, not the class. And that's it for inside the laser script, because when we add it back to the pool is going to take care of disabling the object for us. Now let's move on to the enemy controller, and we do have to do some work here. So in the collision with the laser, this destroy collision.game object, that's destroying our laser. So I'm just going to leave it there, but I'm going to comment out this code while we work on it. So instead of that one, we want to get our object pool.instance.return laser to pool. And then we just need to pass in the same thing. So we can just take this collision.game object. So now when an enemy collides with a laser, instead of destroying the laser, it's just going to move it back into the pool, and then we can use it again. So now we can test this out here. So if we run the game and we start shooting, you can see in the hierarchy, it does keep creating extra lasers, because we initially started with just 25 here. But if we keep shooting, you see the list keeps growing, and they get added back into the queue after it expands. So this is working exactly as it needs to. And once we hit a certain amount that we don't need to expand anymore, it's not going to be creating any new objects. Okay, so we have a working pool now for our lasers. Let's actually add another one in, and we're going to do this for our enemies. So before we actually make this, I just want to mention there are much better ways of doing this for a pool, but they get a lot more complicated in the code and a bit more confusing for starting out. So I'm going to show how to make another queue just like we did and use that for your enemies, and you can make as many different queues in this object pooler as you want, and it's going to run much better than without object pooling. But there is more efficient ways you can do this, so you may want to look into that in the future when you get more comfortable with this. Alright, with that being said, let's just copy and paste these 3 lines in here, and let's just rename laser to enemy for each of these lines, and this is going to create another pool and a pool size for enemies. And everything is going to be pretty much the exact same, just with the word enemy. So in start, let's copy this entire loop, and we'll paste that in, and basically every word of laser in this loop we're just going to replace with enemy. So as you can see, there's a lot of duplicating code, which means it's not the most optimal way, but for starting out I think this is a very easy and simple way to get into object pooling, and it's going to make the performance of your game much better. Okay, so now we're going to copy the get laser from pool method and paste that, and same thing, we're going to replace every word of laser with enemy. So it's the exact same thing, just for our other queue this time. And once again, let's copy the return laser to pool and replace every word of laser with enemy, and now we have all of our methods in place for getting and returning our enemy to the pools now. So that's it for the pool. Adding a new one is that simple. So now we just got to go to our enemy spawner. And now I'm going to comment out the instantiate line. And we're going to get our object pool.instance, and this time get enemy from pool. And then we're going to assign that into a game object named enemy. And now from our instantiate method, we can just copy out that vector3 that we created here. And then we can just do enemy.transform.position and make it equal to that value. And this is going to move it to the exact place where we instantiated the enemy before. We weren't actually using the rotation, so there's no point in setting that. And now we just got to find where we destroy the enemy. So in the enemy controller, if we go to the on collision with laser part in the trigger enter 2D, we can comment out that line as well. And then do the same thing here. We just want to do object pool.instance, return enemy to pool, and then just return this game object. So that should be it. So let's try running this now. And notice our enemy size is only 10 in the pool. If we run it now, we actually forgot to assign our enemy prefab. So let's go to the object pool, drag in the enemy to the prefab slot, and now let's run it again. And actually before that, let's just update our pool sizes so it initializes right at the beginning. So we use a lot of lasers in this game with the multi-shoot, so let's set it to 500. And enemies I'm going to set to 100. We probably use a lot more than that, but either way it'll expand. That'll at least take care of most of it. So if we run the game now, it actually freezes, and that's because we forgot about one more spot where we're actually destroying the enemy and not sending it back to the pool. So that's giving us a null reference error. So if we double click that error, it's going to take us to this point. This is where we got the error. So I'm just looking through any of our scripts for anything that says destroy. And here it is actually on the enemy controller. We forgot when the enemy becomes visible or invisible, we're actually destroying it. So if we copy this line right here and replace that with the destroy, now it's going to send it back to the pool instead. So now let's go and test our game again. So now let's move around, do some shooting, kill some enemies. And it looks like everything's working. And then if you actually look in the hierarchy here, so everything is populating. We have all our lasers and our enemies, and they're going to show dark if they're disabled when they're in the pool, and they're light when they're not in the pool. So, and as I mentioned before, if you just make some little parent objects to parent these under, it'll clean up your hierarchy and you can keep everything separate and nice and clean in there. And I just enabled the stats panel here so we can see our frames per second, and it does look better than previously. It doesn't look drastic, but I mean, right now we're in the closer to 1,000 frames per second, so you're not going to see it as much here. But even so, we're constantly above 750, around 800 here as it is. And before we were, I believe, about 200 frames per second lower. So just those simple changes alone already increase that much performance in our game. And when you start working on a bigger long-term project, that can make a drastic improvement. You always want to make sure you keep your frames per second as high as you can, because if you start dipping under 60 frames per second, your game's really going to look laggy. Well, that's everything for this video. I know it was a long one, so I hope some people do actually find this information helpful. And like I said, once you get used to this, you can branch off of this and make this as advanced as you want it, make it fit your game, custom pools, whatever you need to do. But this should get you going with the very bare bones basics of how to use an object pool. So hope you liked it. Leave comments below of any feedback or anything you think could be better in the next one. And I'll see you guys in the next video.